Hello everyone. So today we'll try to solve a very basic graph traversal problem. And for this problem, we're given a bidirectional graph with n vertices. And we're just trying to find if from one node or one vertex, we can find a path to another one. So our input is n is equal to 3, so number of nodes, edges, which is a two-directional array or 2D array or 2D list in Python, a source, so the node we want to start from, and the destination where we want to end and see if there's a path. So in our first example, from 0 to 2, we have a path. In our second example, between 0 and 5, we do not have a path. So let's take to our notepad and see how we can solve this problem. Hint, we'll use depth first search. So for our problem, we're given a 2D array or edges of a graph, and we're to see if we can find a path between a source and a destination. So for our first example, if we have a graph with edges 0, 1, 1, 2, 0, 2, and those three edges, then we know if we traverse through, we know that we can traverse from 0 to 1 and from 1 to 2 and also from 0 to 2. So we can go one way or another. So we can traverse both ways. So we know there is a path that exists. In our other case, if we traverse from 0, we can only go from 0 to 1, 1 to 2, and 0 to 2, but not from, so we don't have any edge that exists between these two nodes or these two nodes. So we cannot traverse. So in this case, the answer would be false. Note that our source is 0 and our destination is 5. So we cannot traverse. So our possible solution is that we convert the edges that we're given into a graph. So we would have a graph with an edge with nodes that or we graph with a node and other nodes that it connects to. So 1, 2, then we can have 1 with 0, 2, and then we can have 2 with 0, 1. And then we simply traverse and find if there is a path, then we return true, otherwise return false. So let's code it out and see what the solution looks like. Welcome back. So for our solution, we're simply going to we're simply going to create a graph first. So we have def build graph, and it simply takes the edges and spits out a graph. Initialize a graph or a dict, and for edge in edges, we have a comma b is equal to edge. We have 0, 1 in this case would be a and b, and if a not in graph, and we simply initialize it with a key and a value. We would have graph a is equal to an empty array, and same goes for if b not in graph, we would have graph b is equal to empty array. And then since they both connect to one another, we have to append these values. So graph a dot append b, because there's a path from both nodes to one another. So graph B dot append A, and that's it. That's a graph. So let's print out and see what the graph looks like. Print graph, and then we can initialize here. Graph is equal to self dot has graph edges and graph A. Oh, silly me. Wrong brackets. So as you can see, it's a graph that looks just like this for a case, and now we will simply write a function with if the graph has a path. So hasPath takes in the graph, and then it has source and it has destination as well. So if source dot is equal to destination, if we've reached the destination, then we return true. Otherwise, for neighbor in graph, the value that we're returning is a Boolean value, so we can initialize it as a result is equal to self dot has path. We have a graph, source and destination, and then simply if result is equal to true, we return true. Otherwise, if we haven't found our result, then we just return false. If we haven't reached the node, we know that it's not there, or we can't reach it. Return false. And it's simply return self dot has path. We have graph, source, and destination. Now, one thing to note is that if there's a node from 0 to 1 and then 1 to 0, there's a possibility that it will just keep cycling between 0 and 1 and 1 to 0. And we want to avoid that. So we can create a set nodes called visited. Visited is equal to a new set. Set in. We have just pass on the main visited and into the array as well, the recursion as well, and we want to make sure that if source is not in visited, isn't visited, then we just return false, because we know that we have already been here and it's not this. And we also want to add the node to the visited set. So visited dot add source. And I also found a bug where instead of passing source, we want to pass in a neighbor. And let's see what the outcome is like. And there you go. So we wanted true and we got a true. Okay, so there is a bug and we have to find what it is. Oh, there's a small bug here, so we want to make sure that we can graph source. There we go. I hope this helps, and thank you for subscribing.